So today I'm going to conduct a small experiment to verify the hydrostatic principle and the equation. So before starting the experiment, I would like to explain about the hydrostatics and the hydrostatic principle. Hydrostatics is the branch of science which deal with the study of the hydrostatic properties of the water, and the hydrostatic pressure is the pressure exerted by the fluid at any given point, and the hydrostatic principle is the principle that states that the rate of increase of pressure in vertically downward direction must be equal to the specific weight of the fluid at that point, or we can say change in pressure equals to rho times T times H. So for this experiment, we need a clear vessel, we need oil, we need water, and we need a scale, as you can see on the video. So for this, we have to pour the water and oil in the vessel, and then as you can see, it forms a column like that because the density of the oil is greater than the density of the water, so it remains on the top column and the water is on the bottom column. So we have to find out the height of the different columns, the two different columns. So the only difficult thing about this experiment is to find out the height of this column, which I have already done with greater precision, but it can be a slight error, but we have to be really careful while finding out the height of the columns. So after that, we have the experimental setup, as you can see on this paper. This is the experimental setup. This is the oil. This is H2O, P1, P2, H1, H2. So we found out that height 2 of the column, the water column, was 9.7 centimeter and H1 was 2 centimeters, which is equal to 0.020 meters. So the experiment was conducted is conducted in room temperature at 20 degrees Celsius. So the density of water is 998 kilograms per meter cube. So which gives specific gravity of oil 0.8, means it's 0.8 times 998 kilograms per meter cube, which is equal to 798.4 kilograms per meter cube. So the pressure 1, the pressure exerted by the oil in the vessel, is equal to atmospheric pressure plus rho g H1, which gives atmospheric pressure as 101,000 Pascal plus 798.4 times 9.81 times 0.020, which gives the value 101.156 kilopascal or 101,156.64 Pascal. Now the pressure 2. Pressure 2 is the pressure exerted by the H2O at the H2O column, which is equal to P1 plus rho times G times H2, which gives the value 102.106 kilopascal. So as you can see, by finding out the height of the column, we can determine the pressure exerted by the different liquids on the container or vessel. So to find out the total pressure, we can do pressure total equals to P1 plus P2, which gives us the total pressure exerted by the oil and H2O. So which comes out to be 101.15 plus 102.10, which is equals to 203.25 kilopascal. Answer.